Hello all. So today is Unit 2, Day 5, and we are going to about to embark upon the idea of average rate of change. All right, so for a warm-up, we have Danny drives a lot. He's driving to St. Louis, which is 250 miles away. It takes him 4 hours to get there. How fast was Danny driving? So in the world of algebra, we all know that is going to be Danny's average speed. So what you're doing on this one is you're using this formula, distance equals rate times time. And my distance is 250. My my time is 4 hours, so we have 4R. So if I solve that, I get R is 62.5 miles per hour. Okay, so that seems pretty simple, which it is. So what you just did was you found the average rate of change for Danny driving from 0 to 4 hours, so the entire trip. So we'll talk a little more about this later on in the section, because eventually we're going to find like his average speed between the last hour of his trip. So between perhaps 3 and 4 hours. So he could have been driving faster then, or he could have been driving slower then. Okay, so we're also going to review this idea of a difference quotient. So we're going to find the difference quotient of the function 5 over 4x plus 1. So whenever you have a rational, you have to kind of think in your brain that it might be a little more complicated because we're going to have to find a common denominator. So the first thing I'm going to do is go calculate f of x plus h. And then I can just plug that expression into the difference quotient formula. So f of x plus h is going to be 5 over 4 times x plus h plus 1, which is going to be 5 over 4x plus 4h plus 1. Okay, so now if I go to my difference quotient, which is f of x plus h minus f of x all over h. You're going to need to have that memorized, and you're going to need to know how to use it. Okay, so this helps us calculate our average rate of change, which you're going to see as we go later into this section. Okay, so I already know my f of x plus h is this expression right here. So I can just go ahead and substitute that since I've already calculated it. So then I'm going to subtract my original function, f of x, which is 5 over 4x plus 1. I was going to do that in a different color so we could keep track of what's going on. All over h. Okay, so I left myself some room so I could go through and find my common denominator on the top, which is going to be basically the product of those two denominators. So I'm going to have to do this one times 4x plus 1. There goes my dog, as usual. And this one times 4x plus 1. I'm going to have to take this one times 4x plus 4h plus 1. And this one times 4x plus 4h plus 1. So now I'm going to go through and simplify. So I'm going to need to distribute my 5 into the 4x plus 1 and my negative 5 into the 4x plus 4h plus 1. And there's no reason to multiply those denominators. Just leave them exactly the way they are. So on the bottom, I have 4x plus 1 times 4x plus 4h plus 1. In my numerator, I have 20x plus 5. And then if I distribute my negative 5, I have minus 20x minus 28 minus 5 all over h. Don't forget the all over h. Spread out your work so I can help you find your mistake if you make one. Okay, so now if you recall from yesterday's notes, you should be able to cancel everything in this numerator that doesn't have an h with it. So I can cancel out my 20x and I can cancel out my 5s. So I'm left with negative 20h over the denominator 4x plus 1 times 4x plus 4h plus 1. And remember, this h is over 1. So if I bring that up and multiply by the reciprocal, 1 over h, my h's are going to cancel. And my difference quotient is negative 20 over 4x plus 1 times 4x plus 4h. Oops, forgot the 4 plus 1. Okay, so remember, eventually, later on this semester, we'll plug in h equals 0. All right, so now we're going to kind of look at curves and where all this is headed for average rate of change. So for any type of curve, we're starting here with a circle. We have this line called the secant line, which is different from the secant trig function that we did last semester. So this comes from geometry. So a secant line is a line that passes through a curve. At 2 or more points. For a circle, I can have my secant line that passes through these 2 points right here. I could have a secant line that's an actual diameter. If this point is the center. On a circle, it looks like that. If you have a parabola, the secant line could look like this. Passes through the curve here. If you have a polynomial, something that maybe looks like this, you could have a secant line that passes through 1, 2, 3 points. So that secant line is what's going to help us calculate the average rate of change between 2 points on a graph. If we look at the Danny drives a lot problem, so if you think about if we had a curve that represents Danny's speed. So he starts here at 0, maybe 1, 2, 3, 4. We knew it took him 4 hours. And we knew he was going 250 miles to get to St. Louis. So we could actually have a curve represent, so maybe Danny was driving really fast, and then he slows down a little bit, and then he drives faster, and he finally gets to his final location. So what that secant line is going to help us do is if I want to find his average speed between maybe, oh, I don't know, his first 2 hours of driving, and I could calculate the average rate of change for that secant line between the values 1 hour and 2 hours. You can see that his speed is going to decrease as he goes from 2 to about 3 hours, and then he increases as he gets to his final destination. So that's the idea of average rate of change and how it applies to a curve. So if we put that on a graph, the average rate of change is basically your slope of the secant line. To the curve. So if I was to draw a curve here, I'll make it go through some nice points for you. So if I drew a secant line from, let's say, here to here. So if I drew my secant line between those 2 points, I can calculate my average rate of change between those 2 values because I can calculate the slope. This point here, we're going to call A and F of A. You could also use X. Okay, so A would be my X coordinate, F of A would be my Y coordinate. We're going to call this one over here. So here's A. We'll call this one over here point B. This one would be B and F of B. Sorry, I used capital letters there by mistake. Now, if you think about the world of slope, change in Y over change in X, then all I'm doing here is F of B minus F of A, which is your change in your Y values, over B minus A. So now you can find the slope of a secant line average rate of change between 2 points on a graph. And again, this is going to just continue to be looked at throughout the rest of the semester. Okay, so given a function, we know this is a parabola. So I want to find the average rate of change for the function 3x squared minus 5x plus 8 on the interval x equals 1 to x equals 8 over 3. So if you think about that graph, it's going to be a parabola that opens up. I'm finding the slope of the line that passes through those 2 points on the parabolic curve. So the first thing I have to do is calculate my 2 values. So I need to calculate f of 1, which is going to be 3 times 1 squared minus 5 times 1 plus 8. F of 1 is going to be 3 minus 5, which is negative 2. Negative 2 plus 8 is 6. So there's 1 point, 1, 6. So now I need to calculate f of 8 thirds. Get used to using fractions. So 3 times 8 thirds squared minus 5 times 8 thirds plus 8. So f of 8 thirds is going to be 3 times 64 ninths minus 40 over 3 plus 8. Notice how I'm showing my work. F of 8 thirds, and I'm not using decimals, I'm using fractions for exact values. So right here, my 3 and my 9 simplify. So now my denominator is all in thirds, which makes things easier. So I have 64 thirds minus 40 thirds. And I need to change my whole number 8 to a denominator of 3, which would be 24 thirds. So I know f of 8 thirds is, let's see, 64 minus 40. I'm going to have 24 thirds plus 24 thirds, which is 48 thirds. which is a nice number, 16. Again, notice how I showed my work. It's called supporting work. If you don't show me supporting work, you're getting your assignments back for corrections. So now I have another point on my graph, 8/3, 16. Now I can find my average rate of change between the points 1 and 8/3 on the graph of the quadratic. So now I can do f of 16, or I'm sorry, 8/3 minus f of 6 all over 8/3 minus 1 using my slope formula. So I have 16 minus 6, and 8/3 minus 1 is, that would be 8/3 minus 1, that would be 3/3. So it would be 5/3, which is 10 over 5/3, which is 10 times 3 over 5, which is 6. So if you graph that parabola, the slope of the line that connects the two values on the graph, x equals 1, x equals 8/3, the average rate of change, or the slope of that secant line, is 6. All right, so one more rational function. So I think from the previous example, you know you have to calculate your values at -10 and -1, or +1. So this is a rational function. So you could graph it on your calculator and see what it looks like, and kind of eye that secant line going through the points at -10 and +1. So this is 3 times -2 minus 5, which is -20. -30 minus 5 is -35, which reduces 2. If you divide by 5, you get +4/7. So that point is at -10, 4/7. Not a hard concept, it's slope, but now we're finding the slope of curves between 2 points. So f of 1 is 2 times 1 over 3 times 1 minus 5, which is 2 over -2, which is -1. So now I have 1, -1. Between those 2 points on that curve, I'm now going to find the slope of the secant line, or the average rate of change. So I'm going to take f of 1 minus f of -10. There's your change in y2 minus y1, over 1 minus -10. So I have what? Let's see, -1 minus 4/7 over 11, which is going to be, I have to change that to -7 over 7, minus 4/7 all over 11, which is -11/7 over 11, which is -11/7 times 1 over 11, which is going to be -1/7. So, concept not too bad. Just try to get your brain wrapped around what you're actually doing here. So you're finding the slope of a line that connects 2 points on a curve, called the average rate of change between those two x values. All right, have a great day. Make sure you are showing your work when you do all of these problems.